Hi everyone. Today we'll talk about the Hiwonder TonyPi bipedal robot, and we will do an unboxing and a small quick guide on how to run the motors. Here's the box. It's as I said, it's a Hiwonder TonyPi humanoid robot. So we see that this is the front of the box. Here we have a couple of QR codes if you want to check those out, and this is the back of the box. Pretty much the same here all around. So let's try and open it. So it's a bit challenging. I only have one hand here. There we go. So actually, I did take off the robot and already installed it, but I just want to show you what's in there. So you see a ball rolling unit here. So they do include a couple of balls here, just for the they have some feature that you can use for RoboCup, which is basically just robot soccer. So aside from the balls, they have a single screw here. I don't know if you can see that. It's just a single screw. Don't know what that is for. Also, include a screwdriver here. So this screwdriver is just it's just used to screw in the screws of the biped robot. And lastly here, a couple of interesting things. There's two servo motor wires. So that's these things here with the white header. It's having a bit of difficulty zooming on it or focusing on it. So let's see if I can. It's not this day today. So aside from the two servo wires, we have a bunch of screws here, as you see, as well as a couple of servo mounting brackets. So you can mount them exactly how you want. So that is always useful if something breaks down or something like that. All right. So this is the humanoid robot. It looks pretty much the same as on the box. So it includes 16 smart servo motors. Smart servo basically just give you the information feedback, like position, temperature, voltage, all that stuff, which would be useful for like feedback loop control systems. So you have 16 smart servos, as well as just two regular servos. Those are mounted up here. So that's just for the head movement, up and down and left to right type of movement for the head. So that's the camera. Inside here of the torso, we have a battery installed. So you see here the black and red wires just running down and to the back. The battery is 2000 milliamp hour with 12 volts. So let's just see the back, which is the more interesting part. So as you see, I didn't mention this, but it is mounted on a tripod. So the tripod is just there to suspend the biped robot, so that when we come to testing it, we do not break anything. So as you see, the black and red wire from the battery, they run back here, and they connect to this PCB shield. So this PCB shield is just a servo expansion shield for the Raspberry Pi. So that's basically what that is. And just note that the Raspberry Pi, a Raspberry Pi 3B Plus, as well as this servo shield are included in the package, and they come mounted. And then every other wire that you see here is just basically an HDMI to VGA converter. That's for the display over there. Then we have a keyboard wire here, an Ethernet cable, and just the camera for the head here, connected via USB. Originally, I didn't want to use a Ethernet cable, but I was having some problems with the Wi-Fi, with the software that was provided by TonyPi. So that's the OS I'm talking about. Just to go around that, I just plugged in an Ethernet cable, and I'm able to program this humanoid robot via SSH and remote desktop on Windows. So here, just to not drain the battery, they also included this I think it's a 12 volt 5 amp battery charger or something around that. So that just loops around here and connects directly to the battery charging port, as you see here. Just note that the battery is not included within this package, so you'd have to buy it yourself, somewhere like eBay or something like that. It's only for $50, but yeah, that's pretty much it. Oh, and just a quick note. Forgot to mention this, but it was also included in the package. It's a fairly nice tool to have when programming this. It just tells you the battery life of the battery. So it's just a nice display to have, so that the robot doesn't run out of energy while you are using it. So as you see there, it's a bit focused there. But yeah, I guess let's just turn on the robot now. So there's a switch here. I don't know if you can see that, but you just have to turn it on here. Just note that the arms aren't plugged in. And when the Linux system boots, all the servos go back to their default position, so you'd probably see them move a bit now in just a few seconds. So there you go. And yeah, that also does that. The head moves. So let's just go right in the desktop and try to control these servo motors. All right, so as we just did, we just turned on the TonyPi humanoid robot, and it's right to my left here. So we have to wait for the system to boot, and once we have that, all we need to do is just go to the remote desktop, put in the IP address of your biped. So that varies based on your connection. So you click on connect, and you just insert the default username and password, which is Pi and Raspberry, for an SSH connection. And essentially you just wait here, and there you go. So this is the Raspbian desktop. So they do include a 16 gigabyte SD card, so that you don't have to buy an SD card for yourself, for your system. So here are the default softwares that are included. So unfortunately they're in Chinese, so that is a bit unfortunate, but if you do have a Chinese friend, you could get him to translate them. So here are, this is some of the software that they include, basically just to control the humanoid robot, and I think you can like program certain moves that the robot can do. So I think this is the exit button. So we just exit off this one. The second software that they include, which in my opinion would be the most useful for a programmer, is this bus servo program. So what this does is essentially you have to first make sure that only a servo, one servo, is plugged in to the Raspberry Pi. So that ensures that you're reading off only one servo and you're programming only one servo. So here what this allows you to do is read the settings of the connected servo. So if you had, for example, a servo with ID 15, then here would show ID 15 once you click this one, which is the read command. It would also show you parameters such as the deviation, or the voltage range, or the temperature range, and so on. So this would be a very useful tool if you either just starting up or do accidentally mess up the IDs of your servos. So that is very useful. So if we go here, I wrote a small program in Python. So this program only just controls the orientation of each servo motors, not including the motors of the arms. So just the hips, the knees, and so on, just the lower limb joints. So start with just some regular libraries such as like sys, time, and so on. TonyPi does include some very important libraries, such as this config serial servo. So what this does is, if we go see it, config serial servo, it's just essentially a set of functions that you could use in your main program that allow you to control each servo individually based on their IDs. So you see here we have a servo read ID, or servo stop, or set deviation. So that is just the starting position of the servo. We also have things like set max temperature allowed, so that the servos don't overheat, and so on. So overall, it is well documented by TonyPi, and that is very good if you are considering on purchasing this for research or just for having fun. So if we go back to our main .py program that we wrote, so we do just implement a regular PD controller. So we average out the time between samples to be 7 milliseconds, so we just do this. And then all we have to do is set in the desired position of each joint. So here I do a difference between this is the left leg, left arm, right leg, and right arm, so that it's easier for me to set in the specific desired points of each joint. So let me just show you here. So if I decide to put a, for example, a -5 degrees for my desired position. Alright, sorry about that. So let's just get right back into it. I was just talking about how we want to try out the control algorithm. So I'm trying to set -5 degrees here for the left first joint. So I'm just going to zoom in right in there, and so this is a -5 degrees that I am trying to run. So if we press run and just wait a bit, you should see that here you go, the robot has moved slightly by 5 degrees, and similarly we can do that in the other direction as well. We can, for example, set 6 degrees. And by the way, the output here that you see, let's just see, that is the position in degrees. Let's try this instead. So this is the position in degrees of every joint. So all of the 16 joints it shows you. So that's why it's a bit confusing. But you do see there. Oh. What just happened here? Let's try to set it back to 0 and see how that goes. So you see that it does converge to the right one. Similarly, we can here adjust this to 5, this one, so that is the right leg to -5, and then maybe do here a 6, and then do here a I don't know, a 10, for example. And I haven't tried this position, so the two legs might hit each other, but let's hope not. So let's just see here. Alright, we have the camera on, and just run it, and just wait a second, and you see. So we did slightly change the position of joint 1 as well as joint 9. You see they're not very flat with the ground. That's about a deviation of 5 degrees. And we also changed some of the joint angles here. So I'm gonna give it to you from this. Gonna show you this from this perspective. But yeah, you see that the code is working as expected, and yeah, this setup overall has been very nice because it allowed me to to move this robot however I want without doing any damage to it. And there were some cases where the robot did not behave, but overall it's fairly easy to understand after spending a bit of time on it. I guess the next steps now are to implement the walking gate algorithm for it, which should take a fair bit of time. But once that's done, the robot can walk around and have fun. All right, thanks for watching.